Hello friends, welcome back to another video tutorial on SolidWorks. Today in this video tutorial we are going to create a 3D assembly of fuel injection nozzle from my machine drawing book. I have the assembly drawing and the part drawings you can see in front of us on the screen, and we are going to model the whole assembly using the drawings. Okay, every single part. There will be some dimensions missing, but we are going to assume it proportionately and we are going to model it. Okay, the fuel injector is a very important part in the automotive engines. The purpose of the fuel injector is to atomize or break the fuel into fine particles and to direct the spray into the combustion chamber so that every fuel particle mixes with the air compressed in the cylinder. In order to achieve this, the injection takes place through a very fine holes in the nozzle body at a pressure of at least around 160 kg per centimeter square. A fuel injector is also called atomizer, okay, or in short word nozzle. Okay, so I have the book open in front of me. I have also taken the printout of this drawing, so I will not be showing you the drawing every time, but we are going to open it for the critical dimensions. Okay, I'm going to use the drawing I have, and we will model it accordingly. Okay, so I will start SolidWorks in assembly mode. As you can see that most of the time whenever I worked, I modeled any assembly, I started the SolidWorks in assembly mode directly. This is because I model all the parts in assembly directly and then assemble it. This process is also called top-down design approach. Okay. So the first part we are going to model is the body. You can see this body. Okay. This is going to be our first part. Everything else will be modeled keeping this in mind. Okay. As you remember that in a previous video of steam stop valve we had a assembly drawing in which all the parts were shown in assembly and we modeled the entire assembly together. But in this case we can model everything separately also, like we can make all these parts differently and then assemble it. It will be a bottom up approach. Okay. So let's start with SolidWorks. I will go to Insert Components, New Part. Let's name it Body. Okay. Let's open this part. Select Front Plane, Sketch. First we are going to model this part. Okay. There is a fair extrusion here, there is a profile here like rib, but let's concentrate on this portion here. Okay, this portion here is a revolved body. Okay, so first let's model the revolved body. For revolution, first we have to draw a center line, and let's select sketch tool and draw a profile like this. This profile should look a little like this profile. Okay, half the section. We can dimension it accordingly. Okay, the length is 62, the diameter is 15, the upper diameter is 22, this is 16. Okay, so let's dimension it. This is 62. This diameter is 22. this is 16 mm, and this diameter, it is very important. Okay, let me tell you. As you can see that this is M15 into 1.25. M15 is not a standard. Okay, this is not a standard anywhere in ISO or anywhere. But that's why the author has given us the pitch written here also. So the internal diameter will be, the minimum minor diameter will be M15 minus 1.25, nearly 13.75. Okay, but in this case, since these threads are external, we can I'm going to make this 15 mm. Okay, so let's make this 15 mm. Okay, you can see that there is a there is a inner profile also, but I'm not going to model it right now. I'm going to these holes can be done later. First we have to add details, because these kind of details, if we did these holes first and then we added these features, maybe the body will come inside it and we will have to create these features again. So these kind of cuts, we will make all these cuts at the end after the part main modeling is done. Okay, so let's go to features and revolved base. Okay, so this is the first part. Okay, now we have to see which will be the second thing we will model. Let's see. We can model this portion here or this portion here. Okay, I will model this portion here. Okay, this one. So let's I will select front plane, or I can select right plane, whatever you like. Let's select right plane. Sketch. Okay, select circle, normal to, and keep in mind the center point of the circle should be vertical to the origin. Okay, like this. The diameter again, let's see, the diameter is 15 again, so let's make it 15. Okay, the center distance is there should be some center distance here. Okay, they have given it differently. 13 plus 4, 17 plus 7.5. We can calculate it that way, but if you ask me, we never assume, we never take center distance for a tap. Okay, for threads. Okay, okay, we can use this 38 here. Okay, this is given directly here, so let's use 38 mm. Okay, now go to features, extrude. We have to see how much we have to extrude this part. Okay, let me open the drawing. There should be some dimension given. I don't think any dimension is given here. This dimension is not given here because this part is not mating, this portion is not mating with any other part here, so this is not very important here. This is we can adjust this keeping in mind the constraints for the you know, where this part has to be fitted. Okay, so for now let's assume it 35 mm. Okay, these assumptions are first of all, let me tell you, I'm not making any random assumption. I have scaled down the drawing and calculated it. Okay, so keep in mind that whenever I say assume, so I have actually assumed it proportionately. Okay, so the next part, in next part we will model this portion. Okay, go to top plane, sketch, normal to, Okay. 20 from there. Okay. Let's make a center line and make these symmetric. Okay. So according to the drawing, from this point, from this edge, this is a silhouette edge. From this edge to this portion, it is 20. Okay. But there is a radius here 13. Okay. Okay. So from here to here, it is 20 mm. I hold it down the shift key. Okay, left shift key you can see, and then I selected this edge and then this, so that we have a minimum dimension here. Okay, let's convert this to construction. Let's make a arc here. Okay, symmetric. The radius is 13. Okay. The width is 14. Okay. The dimension from here to here, 14. Okay, so this is fully defined. We have to trim down a few details here. Okay. You can see there is a hole here also. Okay. I can use hole wizard later, or I can just do it here. Okay. If you ask my preference, we should always use hole wizard tool, hole feature for these kind of holes, because if your drawing goes to someone else, sometime we have to change the dimension or center distance of holes, and the other designer will be so confused to find out, okay, in which feature there is a hole, and adjusting the sketches. So that's why it is always preferred to make these holes as a feature at the end. But this is not a very important here. We have a drawing, so I can just model it right here. Okay, now we have to extrude it. Okay, so this is at a distance of 22 plus 16, 38 mm, and the extrusion is 6 mm. Okay, I could have made a offset plane from this face to here till here and then created this sketch here, but why should we create a reference plane when we can just use the extrude offset feature here? Okay, I can just write down the offset here. Okay, so I don't need to create a plane here. I can just do it right here. Okay, the thickness extrusion is 6 mm. Okay, so we have modeled two portions here, this portion and this portion. Now we will model these portions. Okay, uh, we have to find out a lot of dimensions here. Okay, so let's see. Okay, we have a 3 mm from here. Okay, the angle is 45 degree. Okay, and there is a 13. Now this is exactly what we needed. This is more than enough what we need. Okay, so let's select front plane, sketch, normal to. Okay, the sketch is something like this. Okay, but let's not make this coincident here. Let's move this inside, because otherwise if I made it coincident on this cylindrical face, we will have a zero thickness error. So let's make this coincident here. Okay, okay, the distance from here, right? Okay, right click this edge, find intersection with this, and the distance here is 3 mm. Okay, the angle is 45°. A lot of dimensions will come automatically if you ask me. Okay, from this edge to this edge we have 13 mm. This is what I am talking about, 13 mm. Okay, this is not very important here. I'm just going to make it so that I don't have any zero thickness error. So let's assume this 20 mm, and features extrude. Make this mid plane. Let's check how much we have to extrude it. There should be some dimension given here. Okay, there is no dimension given here, but I can see it clearly that this is corresponding to this here. Okay, maybe this is not very important dimension here, that's why the author has missed it, removed it. So this is equal to this 14 here, or you can say 15 here. Okay, so let's assume it 14 mm here. Okay, you can see that I have a extra surface here. I can just go to direct editing and delete face. So let's select this face also, and okay. This is a very common error in ribs, so we can use this delete face command to fix these errors. Okay. Okay, so there is a tapping M15 into 1.25. I can do that later. This is not very important. Okay, the important is this here. Okay, this one here. So there should be some center distance. Okay, there is a center distance given 8 till this center, and this is inclined at a 45°. So let's model it. I will select front plane, sketch. First we will need some reference dimensions. That's why I am first plotting something like this, some construction lines. Okay, so from this edge to this point the dimension is 8. Okay, this is perpendicular to this. Okay, let's make this go all the way down. The depth, okay, the depth is not given here. How much it goes until this face. Okay, so this is 15. Okay, this is 15, and to calculate this we have to find out the intersection. We can do that. This is not very difficult. Just draw a center line like this from here to here, and this is 15, so extrude it bidirectional. 15 by 2, 7.5. Okay, let's make these construction also. The dia of this groove is 1.25. Okay, so offset this 1.25 by 2.625. Okay, so this intersection here, this is what we wanted, this one. Let me make these construction. Okay, this point is important. This is still where we will cut it. Okay, so I will just exit the sketch. We have some reference here now. Okay, let's go back to our drawing. This is M6-3. Okay, let's go to features. I have hole wizard here. If you don't have, you can find the command from here, hole wizard. Okay, M6, the depth for the, okay, 3. Let's make it 3 also. Positions, select this face and this point, click OK. Select this face, sketch. The dia for the groove is 1.25. So let's make this 1.25. I'm not going to cut it right now. First I will cut the circle here. Okay, this is M15 into until this point. Okay, so I will draw a circle here. Now keep this in mind, I will make a circle here 13.75. okay, not 15, because 15 is the external the major dia of the thread. Okay, so this will go up to 13. Okay, so extrude cut 13. Now select this face, sketch, and here create a circle of 15. Okay, now features, extruded cut up to this point. Okay, this is not very visible here. In these cases we can change the sketch color. I will make it pink or whatever. Okay, please don't comment that I don't know which color is this. My color knowledge is very bad. Okay, so select extrude cut and now select this circle and double click on this face, click OK. So you can see that we have seamlessly modeled this area here. Okay, we can hide this sketch, we don't need it. Okay, about this here, we have to make the thread. I will choose the cosmetic thread and select this edge here. The major dia is 15 up to 13 mm and start from this plane. Okay, click OK. So we have created cosmetic threads. You can see cosmetic threads from this face to this face. Okay, so basically this part is completely modeled except this here. Okay, this is not very difficult here. First I will want to create this M15 here also. So I will select thread again. Sorry, not thread, cosmetic thread. Okay, in this case the minor diameter is, first let's select the edge from this face. The minor diameter is 13.75. The length up to which it is, this is up to nearly this face. So this was, let's see how much This is 14 mm, so let's make it 12. Okay. There is a thorough hole 5 mm. Let's select top plane. Okay. Sketch. Draw a circle here 5 mm. Features, extruded cut, reverse the direction and through hole. You can also select up to next. Okay, the result is going to be same here in only in this case. Okay, now the main problem here is this. Okay, this 90 degree, this 90 is actually with 8 mm diameter. Okay, and there is a you can see there is a oil hole here all the way till okay, till the end face. So let's make this. I will select this face, sketch, draw a circle here 8 mm, go to features, extruded cut and select draft. Okay, and input 45 degree. 45 plus 45 will be 90. So okay, here it doesn't matter how much you make it. It should be so much that there it should be a value so that there will be a tip here. Okay, now select front plane, sketch. Now we have to make path for our oil hole. Okay, there are many ways we can do it, but I will show you the easiest way. The distance is 4.5. Okay, okay, you can make this coincident on this face or you can make it outside this face. Okay, it doesn't make any difference here. Okay, the dia for the oil hole is 1.25. Okay, so let's select swept cut, circular profile, and the diameter is 1.25. Select this sketch as path, click OK. So we still have there here M15 into 1.25. So let's create threads here. Cosmetic thread, select this face. Okay, cosmetic thread, select this edge from this face, 13.75 up to next, click OK. Okay, in this drawing there is a gap here. You can also make it 15, but this doesn't make any difference. The gap here is so that during making thread, the tool doesn't touch this face. Okay, so that's why there is some gap here. Okay, let's make it a little less. Okay, select this thread, edit feature, and blind, make it 15. So there is a 1 mm gap. Okay, so this part is complete here. Let's go to our assembly. Yes, let's save our part. Desktop, new folder, fuel injection nozzle. Okay, save. Let's save these parts also, so that this is not a internal assembly. Okay, so this is the first part of the fuel injection nozzle. In next part we will make the other parts of this assembly. Okay, if you like this video, please give me a like, and please share this video with your friend and subscribe to my channel. Okay, if you have any problem with this drawing or this particular part, you can message us on our Facebook page or in our WhatsApp group, or you can contact us directly, okay, here in comment section. Okay, thank you for watching this video tutorial and have a nice day.